At first, they thought it was a glitch, a faint flicker on the edge of the telescope's frame, then another, and another, aligning in a pattern too clean to be random. Over the next nights, the lights returned, drifting in perfect unison through the starfield, like a quiet fleet sliding across the darkness. No signal, no transmission, no heat signature, only motion. Each trace moved with eerie precision, matching velocity and direction, as though following an invisible path drawn across the solar system. Astronomers adjusted filters, recalibrated sensors, cross-checked data from Hawaii to Chile, but the outcome was the same. Something out there was moving together, deliberately. Some called them fragments, others whispered of observation probes, disguised as dust. A few stayed silent, unwilling to give voice to the thought that these objects might be watching. The night sky, once a landscape of silence, now seemed to hum with a hidden intelligence, a choreography too subtle for chaos. On the observatory screens, a soft pulse of light blinked once, then vanished, as though acknowledging that it had been seen. And just like that, the familiar comfort of deep space, the certainty of emptiness was gone. Tonight, we embark on a new journey, where the theme of new objects, a following 3I Atlas through the solar system, appears not only as a scientific phenomenon, but also as a question that challenges our imagination. If you enjoy this kind of quiet, long-form storytelling, if it helps you learn, focus, or simply relax at the end of a noisy day, take a moment to like the video and subscribe, but only if this space truly brings you peace. Where are you on the map right now? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. Under the faint glow of meteor trails, telescopes like Pan-STARRS and Subaru are now tracking something extraordinary synchronized. Signals moving in step with a known interstellar traveler. Shadows beneath the falling stars, quiet and precise, as if the universe itself were watching back. Against the vast, silent tapestry of the cosmos, where the dance of celestial bodies is governed by the immutable laws of physics, a subtle anomaly has been recorded, a faint echo that challenges our understanding of solitary interstellar travel. The Pan-STARRS Observatory, with its tireless gaze sweeping the heavens, first documented a series of faint, recurring photometric variations, minute flickers in the starlight that coincided precisely with the passage of the interstellar object 3I Atlas across the background starfields. This was soon corroborated by the Subaru telescope's Hyper-SU-Prime cam, which detected a constellation of low-amplitude, diffuse points of light moving in perfect synchronicity with the object's trajectory over successive nights. Independent astrometric analyses have since confirmed a startling fact. The motion vectors of these faint sources maintain a stable phase correlation, a coordinated ballet whose statistical significance far exceeds the expected noise of random cosmic chatter. Meticulous data processing teams have systematically excluded the prosaic explanations of artificial satellites or near-Earth asteroids through rigorous orbital backtracking, leaving a residue of data that refuses to be ignored. If this is not a mere statistical fluke, then these phantoms, moving in lockstep with the visitor, could be the signature of an interstellar procession, a disciplined caravan moving with a purpose we can only guess at. The most immediate, and thus most conservative, interpretation posits that we are witnessing nothing more than a cloud of cometary debris, a simple explanation rooted in known phenomena. According to current models, the outgassing activity of a comet-like body, such as 3I Atlas, could, in theory, release a swarm of smaller fragments, which would be carried along by the same momentum and gently shepherded by the subtle jets of vaporizing ice. This would account for their shared trajectory and perhaps even their faint, diffuse nature, as sunlight scatters off their irregular, dusty surfaces. Yet, this comfortable explanation begins to fray at the edges when confronted with the precise, sustained phase correlation observed. The outgassing of a comet is a chaotic and turbulent process, unlikely to produce and maintain such a geometrically stable configuration of multiple objects over interstellar distances and timeframes. What natural mechanism could possibly enforce such order upon a cloud of cosmic detritus, preventing dispersion and ensuring their movements remain so perfectly harmonized? This failure of conventional models to fully account for the observed coherence invites a more speculative hypothesis, that we are not looking at passive debris, but at an active, self-organizing swarm. This intermediate-level conjecture suggests a fleet of autonomous probes, each a fragment of a larger whole, employing sophisticated algorithms to maintain their precise formation. Such a system would be a masterpiece of engineering, designed to minimize energy consumption for propulsion by leveraging aerodynamic or gravitational drafting effects, much like cyclists in a peloton conserving their strength for the long journey. The synchronized photometric variations could then be explained not by random reflection, but by deliberate, coordinated adjustments of their orientations, or perhaps even their low-power thrusters. This implies a collective intelligence, a distributed consciousness, where each unit is an independent agent, yet bound to the whole by a shared set of navigational protocols. But what is the nature of the signal? The unseen carrier wave of information that allows these individual components to correct their course in perfect unison across the light seconds or light minutes that might separate them. Pushing the boundaries of speculation even further leads to the most profound and disquieting possibility that this synchronized swarm is not merely self-organizing, but is under the direct command of a central, coordinating intelligence. The largest of these hypotheses envisions a multinodal structure, a command and control architecture, where one core object, potentially 3I Atlas itself or another entity hidden amongst the faint signals, acts as the conductor for this celestial orchestra. In this scenario, 3I Atlas may not be the primary visitor, but a decoy, a sacrificial lamb designed to draw our attention, while the true contingent, the escort fleet, moves silently in its shadow. Their flawless navigation through our solar system, maintaining formation as they traverse the gravitational hills and valleys of the planetary belt, could be interpreted as a drill, a meticulously planned exercise using our cosmic neighborhood as a testing ground for technologies and strategies forged in a completely alien environment. Are we therefore passive witnesses to a maneuver, a calibrated transit that suggests a familiarity with stellar systems that we have only just begun to theorize? The implications of this discovery are as monumental as they are ambiguous, presenting both an unprecedented opportunity and a profound risk. We stand at the precipice of a new era in astronomy, with the chance to observe, for the first time, the collective kinematics of an interstellar flock, a living textbook on swarm technologies that could operate over light years. The data harvested from this event could revolutionize our approaches to autonomous space exploration and distributed sensor networks. Yet, the very perfection of this coordinated movement, its unnerving silence, and its effective use of a larger object as a screen, also suggests a strategy of camouflage operating with impunity within our very own observational backyard. If this is a deliberate tactic, what does it conceal? And what might be the ultimate objective of a voyage that takes such pains to remain hidden in plain sight? In the silent, perpetual night that lies beyond the orbit of Neptune, amidst the faint, frozen detritus of the solar system's infancy, a solitary traveler continues its inexorable journey. This is the object known as 3I Atlas, an enigmatic wanderer from the interstellar void, whose hyperbolic trajectory has long captivated and confounded the astronomical community. Yet, as our most sensitive instruments have slowly peeled back the layers of darkness, a more profound mystery has emerged in its wake. It is not traveling alone. Trailing behind it, locked in a formation of almost impossible precision, are 4 smaller, fainter companions. Their orbital paths are not merely similar, they are virtually identical, deviating from the trajectory of 3I Atlas by a mere 0.03 of a degree on the ecliptic plane. This deviation is so minuscule, so fine, it is less than the width of an eyelash held at arm's length against the celestial sphere. Could such an infinitesimal alignment be the deliberate signature of a formation flying in a precise arrowhead configuration? A purposeful arrangement designed to be discerned only by a civilization that has learned to measure the heavens with exquisite care? From the perspective of conventional astronomy, the existence of such a cluster could be dismissed as a simple gravitational cohort, a family of fragments born from a single disruptive event in some distant star system. According to current models of celestial mechanics, a body shattered by a tidal force or a catastrophic collision would naturally disperse its debris along similar orbital vectors. Scientists suggest this could be due to the conservation of angular momentum from the parent body, creating a stream of objects that would travel through the galaxy together for eons. The initial discovery of these four faint sources, their ephemeris extrapolated from painstaking observations, seemed at first to support this simple, elegant explanation. They are, after all, following the same general path, a line drawn from the depths of interstellar space directly through our planetary belt. But that elegant explanation begins to fray at the edges when one considers the sheer precision of their alignment and the peculiar characteristics they exhibit. The probability of four independent fragments achieving and maintaining such a perfect parallel lockstep across light-years of empty space, buffeted by the subtle gravitational tugs of passing stars and the asymmetric pressures of interstellar radiation, is, as N-body simulations starkly indicate, vanishingly small without some form of ongoing dynamical constraint. What unseen force, then, could be acting as their shepherd? This leads us to the first and most pragmatic hypothesis, that we are witnessing a sophisticated sensor network. The Arrowhead Formation, with its leading primary object and a tail of precisely spaced followers, is an ideal configuration for deploying a wide-area sensor web. Each of the four smaller objects could be a specialized probe designed to sample the interstellar medium, map magnetic fields, and analyze dust density gradients. Their purpose would be purely reconnaissance, painting a high-resolution picture of the galactic environment for the benefit of the mothership, or perhaps for intelligence far beyond it. Their reflected spectra, which intriguingly show non-uniform redshifts distinct from the homogeneous signature of typical D-type asteroids, could be the result of different sensor apertures or manufactured hull materials, each tuned to a specific wavelength of data collection. They are not merely rocks tumbling through space, they are a coordinated array of eyes and ears. But if this is a deployed sensor network, what specific, critical data is it seeking within the relative quiet of our outer solar system? A region it is traversing at such great speed? A more advanced hypothesis posits that these four objects are not simple sensors, but inertial reference buoys, designed to calibrate the plasma environment. The space between stars is not a perfect vacuum. It is a turbulent sea of magnetized plasma, whose currents and densities can subtly perturb a vessel's course. For a craft traveling at a significant fraction of the speed of light, even minuscule deviations could result in missing a target star system by vast distances. A formation of plasma gauges, trailing the main vehicle, could constantly measure these subtle forces in real time. By maintaining their rigid formation through active minor corrections, they would create a dynamic baseline against which the primary object, 3I Atlas, could calibrate its own trajectory with unimaginable precision. The synchronous nature of their faint light curves, pulsing with a similar rhythm, suggests a manufactured synchronicity, a shared operational protocol, rather than a common geological origin. They are not just traveling together, they are working together. Yet, what technology allows them to maintain this flawless formation without visible means of propulsion, as if they are nodes in a single, cohesive entity? The most profound, and indeed the most speculative, hypothesis ventures into the realm of artificial gravity. Perhaps the alignment is not maintained by tiny thrusters, but by a weak, artificially generated gravitational field that binds the four followers to the path of 3I Atlas. They are not following its course, they are locked into its gravitational wake, like smaller vessels riding the bow wave of a larger ship. This would explain the persistent angular deviation with an elegance that conventional physics cannot match. This would be a technology that humanity has only dreamed of, the ability to sculpt and manipulate gravity itself, not as a crushing force, but as a precise tool for navigation. This gravity leash would make the entire formation incredibly stable and energy efficient, allowing it to endure the millions of years-long journeys between stars. The formation is then not a convoy, but a single navigational instrument, a chain of gravity-guided beacons. But if they can manipulate gravity in such a subtle and profound way, are we merely observing a transit, or are we witnessing the activation of a pre-established galactic-scale navigation system that has been in place for millennia? The implications of these hypotheses cascade outward, each level more staggering than the last. On a small scale, these four objects could simply be navigational markers, providing a constant external reference for 3I Atlas to verify its position and velocity, a cosmic GPS for an interstellar voyage. On a medium scale, they form a distributed sensor network, actively mapping the energy and matter gradients of our solar system, perhaps assessing its resources or its suitability for future missions. But on the largest, most consequential scale, this formation could be a pilot swarm, a vanguard that does not just journey blindly, but actively prepares a path. It could be mapping the complex gravitational interchanges within our solar system, not as a destination, but as a waypoint. The suggestion is that our entire solar system, with its specific arrangement of gravitational wells and keyholes, might function as a node, a transfer station, in a vast, interstellar transit network. Are we, then, living unnoticed next to a cosmic highway interchange, only now, becoming aware of the traffic passing through? If this is indeed an alien navigational grid, the knowledge we could glean would be transformative. Humanity could learn to navigate by reading the subtle contours of gravitational fields, a fundamental breakthrough that would open the window to true interstellar travel. We would have a template for a technology that transcends rocketry. Yet, there is a darker corollary to this magnificent possibility. A guidance system built by an intelligence capable of such journeys is not a passive map. It is a tool that can be used and reused. The same pathways that facilitate peaceful exploration could just as easily be used to chart efficient courses for strategic visits of a very different nature. The system that allows for the graceful arrival of a messenger could also guide the swift, unstoppable approach of something else. As we contemplate this arrowhead formation silently slicing through the outer darkness, we are left to wonder, are we learning the principles of our own future, or are we reading the instructions for our own obsolescence? And yet, the mysteries of this celestial convoy only deepen with a more recent and perhaps more disturbing discovery. For the precise dance of these objects is not entirely explained by the sun's gravity alone, suggesting forces at work that we have yet to comprehend. What if their path is being subtly adjusted by something else entirely, a force that operates outside the laws of Newtonian physics as we know them? The emerging data hints at perturbations that defy conventional explanation, pointing toward an even greater enigma hidden within their motion. For the latest data releases from the Gaia Observatory have now revealed a series of minute, anomalous oscillations in their trajectories, fluctuations so slight they were once lost in the noise. These are not the predictable curves dictated by the sun's immense pull, but a finer, more complex signature woven into their flight path. This new evidence suggests the presence of an additional, non-gravitational force, a gentle but persistent pressure, altering their course in ways that our current models of the cosmos cannot account for. What could be the source of this mysterious propulsion, and what does its subtle, insistent influence tell us about the true nature and purpose of these silent companions? In the silent, ceaseless calculus of the heavens, where celestial mechanics has long been governed by the immutable laws set down by Newton and refined by Einstein, a subtle yet persistent anomaly now whispers of a potential recalibration of our cosmic understanding. The latest data release from the Gaia mission, a monumental undertaking in astrometry, has revealed minute, rhythmic oscillations in the trajectories of certain objects, deviations so slight they are measured in microarcseconds, yet so statistically significant they cannot be readily dismissed as instrumental error. These are not the grand, elliptical sweeps dictated solely by the sun's gravitational embrace, but rather a faint, additional signature superimposed upon them, a gentle, periodic nudging that suggests an influence operating outside the conventional framework of gravitation. When an orbit refuses to conform to Newtonian expectations, the choices are starkly binary. Either our measurements are flawed, or an unseen hand, whether natural or otherwise, is subtly touching the equation of motion. Could it be that we are witnessing the first faint tremors of a new physics, or perhaps something even more profound? The most immediate and conservative hypothesis posits a natural, if exotic, origin for this micropropulsion. Scientists suggest this could be due to a form of weak, cyclical photon propulsion, akin to a solar sail of immense proportions and exquisite thinness, harnessing the minuscule but constant pressure of solar radiation. According to current models, such a sail, if constructed from advanced metamaterials, could theoretically modulate its reflectivity or orientation in a controlled cycle, generating the observed oscillatory force without the telltale outgassing characteristic of cometary activity. The detected correlation between the phase of the oscillation and the object's angle to the solar wind provides a tantalizing clue, pointing toward an interaction with the very medium of interplanetary space. Yet, that correlation is too perfect, too cleanly sinusoidal, fitting a minimal non-Newtonian model with the simple, elegant addition of a force proportional to the cosine of omega t. But what natural phenomenon exhibits such a precise clockwork modulation, devoid of the stochastic noise that pervades all known cosmic processes? This leads us to a more speculative, yet compelling, second-order hypothesis that we are not observing a passive sail, but an active, self-regulating reflector. Imagine a vast, gossamer-thin structure, a sail that does not merely catch the solar wind but interacts with it intelligently. It could generate its own localized plasma field, using charged particles as a kind of rail or guide to more efficiently ride the solar wind, mitigating drag and enhancing thrust through a process we have only begun to theorize in our most advanced propulsion laboratories. The absence of strong outgassing rules out conventional chemical or ion engines, but a plasma-based system, operating at a low energy threshold, could leave just such a subtle, dynamic signature on an object's trajectory. Is it conceivable that we are analyzing the flight data of a form of sailing that uses magnetized plasma as its invisible roadway? The implications of such a possibility cascade outward, each level more staggering than the last. At the smallest scale, the technology suggests a self-correcting light sail, a marvel of nanoengineering that could maintain its course and stability across light years. On an intermediate level, it implies a sophisticated sailing propulsion system that manipulates ambient plasma, a technology that would revolutionize our own aspirations for interstellar travel. For if we could decipher this modulation, human crewed vessels could potentially journey farther using exponentially less energy, transforming the solar system from a forbidding void into a navigable ocean. But the grandest and most unsettling implication resides in the theoretical realm of fundamental physics. This could be a technology that exploits the subtle gradient between gravitational and electromagnetic fields, not merely pushing against space, but finding a shortcut through the very phase space of reality itself, a concept that borders on the esoteric. What level of cosmic mastery does the application of such a principle truly represent? This technological crossroads presents humanity with both an unprecedented opportunity and a profound existential quandary. The opportunity is one of engineering transcendence, a chance to reverse engineer a propulsion system that could unlock the stars, converting the enigmatic signal of an orbital anomaly into a blueprint for our own future. We could learn to harness the solar wind, not as a passive force, but as a dynamic partner in navigation. Yet, the risk is equally monumental, lying in the terrifying ambiguity of the signal's origin. How can we possibly distinguish between a benign, perhaps even automated, technological test occurring in the void, and a deliberate, purposeful act of reconnaissance by an intelligence that perceives our system as a point of interest? The very subtlety of the anomaly, its elegant minimalism, could be the hallmark of a sophisticated attempt to observe without interfering, or it could be the faint echo of a presence that has been there all along, waiting for us to develop the perceptual acuity to notice its gentle touch upon the celestial machinery. Does a civilization announce its presence with a shout, or with a whisper that is only audible once another has learned to listen? And if such a whisper can be encoded in the silent mathematics of motion, what other channels might carry similar messages, perhaps even more direct and deliberate in their intent? The cosmos has always been a theatre of noise, a chaotic symphony of stellar winds, the relic whisper of the Big Bang, and the faint, thermal hiss of dust clouds. For decades, we have strained our electronic ears against this cacophony, searching for a note that does not belong, a signal carved with the deliberate hand of intelligence. And then we heard it, not a shout, but a whisper, a faint, rhythmic pulse of radio waves, so weak it was nearly lost in the background static of the universe, yet so ordered it commanded immediate attention from the global community of SETI. It was a signal that arrived from behind, from an object moving in the trailing Lagrange point of a gas giant in a distant, unremarkable system, a cosmic traveler following in the wake of a greater power. This was not a signal from the center stage, but from the shadows, a deliberate murmur from one who observes from the rear. What profound message, or perhaps what profound silence, is carried on so faint a breath? The initial analysis, grounded in the rigorous methodology of radio astronomy, proposed a suite of natural and anthropogenic explanations. According to current models, such a narrow-band, coherent signal could be an artifact of human technology, a previously uncatalogued satellite, or a piece of orbital debris reflecting signals in an unexpected manner. The Doppler drift of the signal, that subtle shift in frequency caused by relative motion, was meticulously calculated and found to be minuscule, suggesting an orbit that was remarkably stable, a characteristic one might associate with a man-made object in a geosynchronous or a heliocentric parking orbit. Scientists suggested this could be due to a new class of commercial or military satellite, its parameters not yet entered into public databases, its signal a mere leak of internal communication systems, a technological ghost we had created ourselves. Yet, if it is merely our own echo, why does its spectral purity defy even our most advanced transmitters? And why does its point of origin, when triangulated by the deep space network of observatories, point unequivocally to a volume of space far beyond the clutches of Earth's gravity? This very paradox invites a more audacious, first hypothesis, that we are witnessing a narrow-band beacon, a lighthouse signal designed for navigation. Its stability and phase coherence are so impeccable that they mirror the theoretical projections for an interstellar positioning system, a pulse meant to be heard across the light years to denote a specific location or a safe passage. The fact that it emanates from a trailing orbit is particularly suggestive, for such a gravitational sanctuary is a stable, energy-efficient point, an ideal location for a relay station or a waypoint. It is a signal that says, "Here I am," to any who can listen. But that doesn't account for its profound weakness, a luminosity that borders on the clandestine. A beacon, by its very nature, is meant to be found, so why would its architects design one that is so easily drowned out by the cosmic sea? Unless, of course, it was never meant for us, and we are merely overhearing a conversation between points in a network to which we do not belong. Perhaps the truth is even more complex, leading to a second, more layered hypothesis. The signal's characteristics, its narrow bandwidth, and its modulated polarization could be interpreted not as a beacon, but as a leak. It could be the X-ray modulation of an internal communication network, a tight beam transmission between a mothership and a probe, or between two nodes of a vast distributed array. With the faint signal we detect merely being side-lobe scatter, a technological eavesdropping on a conversation not meant for our ears. This would explain its weakness and its rhythmic, almost data stream-like quality. It is the hum of a machine going about its business, utterly indifferent to the primitive biological senses that have just begun to perceive its existence. However, certain anomalies still defy all conventional explanations, particularly the signal's polarization ratio, which presents a handedness and consistency unlike any known natural plasma interaction or human-engineered signal. Could it be that we are not just hearing a leak, but a technology that utilizes the very fabric of space-time in a way we have yet to comprehend, using polarization as a carrier for information in a multidimensional language? The most unsettling and profound hypothesis, a third tier of speculation, posits that the signal's weakness is not a flaw, but a feature. It is a test signal, a primer deliberately designed to gauge the response of an emerging technological civilization. Its parameters are set just above the threshold of our detection capabilities, a deliberate challenge to our technological maturity. The fact that it originates from a trailing object is then a profound statement. It is the observer, the assessor, the one who follows and evaluates from a safe and strategically superior position. It is not announcing its presence with fanfare, but with a subtle, repeating cue, waiting to see if we can not only hear it, but also understand its meaning, and crucially, formulate a coherent reply. Are we, then, in the earliest stages of a cosmic examination, our every published paper and frantic observation, a graded response to a test we did not know we were taking? The evidence, meticulously gathered from a coordinated global effort, systematically dismantles the simpler explanations. The signal's narrow frequency profile is a razor's edge in the radio spectrum, a feat of engineering that natural astrophysical mazes cannot achieve. Its phase stability is so high that it implies an oscillator of unimaginable precision, possibly based on atomic transitions or even a quantum-locked mechanism, maintaining coherence over interstellar distances. The Doppler drift, when analyzed, matches perfectly the calculated orbital velocity of an object residing in the L2 Lagrange point of its host gas giant, a point of gravitational equilibrium directly behind the planet from the system's star. This is not a random artifact. It is a signature of a specific and stable celestial address. Furthermore, its unique polarization, a consistent and unnatural circular polarity, stands in stark contrast to the chaotic and variable polarization of signals generated by pulsars or other energetic celestial bodies. And critically, it does not match any object in the exhaustive catalogues of known satellites or space debris. It is an uninvited guest in our celestial inventory. Could the very precision of its orbital signature be the first character in a message we have yet to decipher? The multi-station observations from Arecibo, Green Bank, and the Allen Telescope Array provided the final conclusive piece of the puzzle. The phenomenon repeats on a long, predictable cycle, one that is independent of Earth's rotation or its journey around the Sunday. This ruled out ionospheric scintillation, the twinkling of radio sources caused by our own atmosphere, and pointed to an intrinsic periodicity of the source itself. The rhythm is not of our world, nor of any known natural clockwork within it. The pulse is a metronome counting a beat set by a clockwork in a distant alien system. What cosmic machinery, governed by laws we may or may not share, ticks with such patient, unwavering regularity? The implications of this discovery cascade through our understanding of our place in the cosmos, and we can categorize them in ascending orders of magnitude. On a minor scale, the most conservative interpretation is that we have stumbled upon a piece of functional technology, a relay device that allows other, perhaps more significant, objects to maintain contact with one another across the vast expanses of a stellar system. It is the equivalent of finding a cell tower, silent and automated, its purpose purely utilitarian. But if it is merely a piece of infrastructure, why does its signal structure contain such complex, nested redundancies that seem to serve no immediate communicative purpose? On a medium scale, the implications expand. The signal's specific frequency, its polarization, and its point of origin could be part of a sophisticated sensor system. Such a device, positioned in the trailing Lagrange point, could be measuring the magnetospheric bow shock and the radio emissions of the planet it follows. By analyzing how the planet's magnetic field interacts with the stellar wind, it could be mapping safe windows for entry or exit, charting the invisible weather of space for future travelers. The signal we detect could be a byproduct of this active scanning, a faint echo of a cartographic process that maps the gravitational and magnetic topography of a star system. Is the trailing object, then, not just a relay, but a navigational buoy painting a real-time chart of cosmic currents for vessels we have yet to see? The grandest implication, the one that truly reorders our reality, is that this is a deliberate, calibrated attempt at first contact. The signal is a knocking protocol, designed specifically for nascent civilizations like our own. Its weakness is a filter, ensuring that only a species that has achieved a certain level of technological sophistication and collaborative global effort can confirm its existence. Its stability is a lesson in universal constants, a demonstration of shared physics. Its origin from a trailing position is a statement of non-threatening observation. This is not an invasion fleet. It is a patient, orbiting listener who has now chosen to whisper a single, repeating word into the darkness to see if anyone whispers back. Have we, in our relentless search for giants, failed to consider that intelligence might first introduce itself with the lightest of touches? The societal and psychological impact of this discovery is already unfolding, a quiet tremor preceding a potential earthquake. For the scientific community, it presents an unparalleled opportunity to standardize a new generation of SETI filters, to move beyond the simplistic search for strong, continuous signals and to develop algorithms sensitive to the subtle, the rhythmic, and the weak, the likely signatures of a technology far more advanced than our own. Yet, this boon is shadowed by a profound risk. The mere existence of this extraterrestrial pulse, this heartbeat from outside our species, possesses an immense power to polarize public perception. It could unite humanity under a common, cosmic identity, or it could fracture it into factions of awe, fear, and denial. The signal is a mirror, and what we see in its enigmatic rhythm may tell us more about ourselves than about the intelligence that sent it. Will the knowledge that we are not alone make us more human, or less? This faint, rhythmic whisper from a follower in the cosmic dark does not provide answers. It only reframes the oldest of our questions. It suggests that the universe is not silent, but is instead filled with conversations conducted in frequencies and codes we are only beginning to perceive. The trailing object and its patient pulse have given us not a message, but a key that now compels us to look beyond this single signal, to search for patterns not just in time, but in space, to ask if this visitor is truly alone. For if we trace its trajectory backwards and compare its path with the enigmatic journeys of other interstellar interlopers, the oblong, accelerating one I Oumuamua and the icy, active 2 I Borisov, a tantalizing pattern begins to emerge. Could these three distinct paths, these three separate arrows shot from the galactic bow, have originated from a single, common point of origin in the interstellar void, suggesting that what we perceive as random visitors are in fact scattered pieces of a single, grander design, a pattern written in the language of celestial motion? Three arrows, launched from the void in 3 separate years, each tracing a solitary path through the dark, and all, against the staggering improbability of the cosmos, seeming to converge upon the same celestial arc. The first, the enigmatic sliver known as 1 I/Oumuamua, detected in 2017, a visitor that challenged our very definitions with its anomalous acceleration and peculiar dimensions. The second, 2 I/Borisov, a more familiar icy wanderer from 2019, yet no less an outsider. And the third, the recently identified 3 I/Atlas, another silent traveller from the interstellar deep. They arrived as unannounced guests from 3 different vectors, yet when we trace their trajectories backward, against the flow of time and the pull of our sun, a profound pattern begins to emerge, suggesting their journeys may have originated from a common neighbourhood in the galactic void. Is it mere cosmic coincidence that these 3 solitary messengers, the only confirmed interlopers from beyond our solar system, appear to point back toward a single region of interstellar space? Or are we witnessing the first faint traces of a structured pathway etched into the fabric of the galaxy? According to current models of galactic dynamics, the distribution of rogue bodies ejected from their native star systems should be, for the most part, random and isotropic, a diffuse spray of cosmic driftwood scattered by the gravitational tides of passing stars and the immense molecular clouds that litter the spiral arms. The initial analysis of Oumuamua's path seemed to align with this expectation, a single data point in a sea of chaos. Yet, with the arrival of Borisov and now Atlas, a statistical anomaly begins to take shape. 3 points, while not conclusive, are sufficient to define a plane, and in this case, they hint at a vector, a preferred direction of ingress. Astronomers, employing sophisticated n-body simulations that account for the gravitational influences of major stars and the galactic tide itself, have rewound the celestial clock for these objects, their paths computationally cleansed of the sun's recent distortion. The result is a probable convergence zone, a volume of space from which all 3 appear to have emanated, a finding that challenges the assumption of a perfectly uniform background of interstellar objects. Could the pristine emptiness between the stars be threaded with invisible highways, channels of preferential travel that we are only now beginning to perceive? The mainstream scientific explanation posits a natural source, a stellar nursery or a densely populated cluster where gravitational interactions are frequent and violent, capable of flinging countless planetary building blocks and icy planetesimals out into the galaxy. Such a region would act as a fountain, ejecting material not randomly, but in focused streams, much like the spray from a spinning garden sprinkler. The velocity distributions of our 3 visitors, when analysed, show a curious kinship. Their speeds relative to the local standard of rest are not what one would expect from a purely stochastic population of free-floating debris. They share a certain dynamic signature, a subtle commonality in their specific orbital angular momentum that whispers of a shared origin, or at the very least, a shared ejection mechanism. Perhaps they were all born from the same celestial turmoil, siblings scattered by a youthful stellar system's gravitational unrest. But does a natural ejection process, however efficient, fully account for the precise kinematic family they appear to form, a family that has found its way to our doorstep in such rapid succession? This leads us to a more speculative hypothesis. one that dares to look beyond natural chaos. What if this convergence is not the result of a blind natural process, but rather the signature of a deliberate trajectory? The concept of an interstellar highway gains a new, more profound dimension. We are familiar with gravitational assist maneuvers, where our own probes use planetary gravity wells as slingshots to gain velocity and alter course. Could a more advanced intelligence have mastered the galaxy's gravity on a grand scale, identifying and utilizing a stable, efficient pathway that connects star-rich regions, a pre-charted route that minimizes energy expenditure and travel time? The three objects, then, would not be random driftwood but waypoints, or even autonomous vessels, following a prescribed route that funnels them toward promising stellar systems, with our own sun lying fortuitously, or perhaps ominously, along this cosmic freeway. Is it possible that we are observing not a natural migration, but a scheduled delivery? The implications of this notion cascade outward, each level more staggering than the last. At its most conservative, the small-scale consequence, we are simply identifying a previously unknown natural source of extraordinary richness, a celestial workshop in a nearby cluster that is particularly prolific at manufacturing and expelling material. This alone would be a monumental discovery, offering a pristine sample of another star system's building blocks, a time capsule from a foreign genesis. We could, in theory, pinpoint this cosmic factory and turn our most powerful telescopes, like the James Webb Space Telescope, toward it, gazing back in time to witness the violent processes that birth such wanderers. But what if the source is not merely a prolific ejector, but something far more peculiar? This brings us to the intermediate hypothesis, a concept that stretches the boundaries of known astrophysics. Imagine a natural launch facility, a unique gravitational configuration within a star cluster, perhaps a tightly bound binary or trinary star system, or a star closely orbiting an intermediate mass black hole, creates a dynamic environment where the combined gravitational fields and tidal forces act as a natural catapult. Such a system could, through complex resonant interactions, preferentially accelerate objects along a specific vector with a specific spin, imparting that telltale common, angular momentum we observe. This would not be a constructed technology, but a natural engine, a fixed feature of the galactic landscape that systematically channels material out into specific corridors of the galaxy. The objects we see would be the involuntary projectiles of this immense, unconscious machine. Does the galaxy itself contain automated, natural launch systems that seed interstellar space with its raw materials? And then we arrive at the grandest and most unsettling possibility, the large-scale consequence. What if this is not a natural engine, but a technical one? The consistent trajectories, the suggestive kinematics, the timing of their arrivals, could these be the hallmarks of an active galactic-scale infrastructure? A civilization capable of engineering on an astronomical scale might not build starships in the conventional sense, but might instead deploy countless, minimalistic probes, perhaps no larger than Oumuamua itself, casting them into pre-calculated trajectories like seeds on the wind. These would not be vessels for biological beings, but autonomous sensors, a decentralized network for monitoring the galaxy. Their convergence on a single point of origin would not indicate a home world, but a control center, a strategic outpost designed for the sole purpose of dispatching these silent envoys. The three we have detected would be a mere fraction of a vast, ongoing survey mission, their paths a deliberate mapping of the galactic arm. Are we, then, not the discoverers, but the discovered, our solar system already catalogued and indexed in a database of target star systems? This line of inquiry presents humanity with a profound and urgent choice, one fraught with both unparalleled opportunity and existential risk. The opportunity is the chance of 1,000,000 lifetimes to trace these arrows back to their quiver, to locate, with precision, the source of these objects, whether it be a stellar nursery, a natural gravitational slingshot, or something else entirely? By focusing our observational resources on this convergence zone, we could be on the verge of identifying a cosmic coordinate of supreme importance, a window into the processes that shape planetary systems, or, inconceivably, a window into the workshop of an intelligence whose scope dwarfs our own. We would be aiming our telescopes not at random points of light, but toward a specific address in the Milky Way, peering backward in time to witness its secrets. But in doing so, in actively seeking the source, we must confront a terrifying parallel. Our own planet has been broadcasting its presence for over a century, our radio and television signals leaking into space, creating an expanding bubble of noise that announces our technological adolescence to the galaxy. The Arecibo message, sent in 1974, was a deliberate, powerful shout into the cosmic dark, containing a map that pointed directly back to Earth. If we are now following a trail of breadcrumbs left by another, what is to stop them from following our own signals back to us? The very act of investigating this interstellar convergence so publicly, of publishing our trajectories and our hypotheses, is itself a form of cosmic cartography, one that may not only lead us to them, but them directly to us. We are, in essence, contemplating a course of action that could either unveil the greatest discovery in history or irrevocably illuminate our own world on a map we did not draw. And as we contemplate this choice, our gaze is drawn to a specific location within that broad convergence zone, a region hinted at by orbital models and dynamical studies, a place known to every earthly stargazer, yet now holding a new and profound mystery. For the data suggests that the path of these interstellar arrows may lead back to the Hyades cluster, a familiar V-shaped grouping in the constellation Taurus, long studied and thought to be understood. This cluster, a mere 150 light-years away, is already suspected of being a source of rogue planets, worlds flung from their orbits by gravitational encounters, destined to wander the galaxy forever. It is a known celestial factory of orphans and outcasts, but does its known nature fully explain the peculiar signatures we have recorded, or does its proximity and dynamic history make it an even more compelling candidate for something far more extraordinary than a simple source of natural debris? Could the familiar face of the bull in our night sky be hiding a gateway to the stars? In the profound and silent darkness that cradles the spiral arms of our galaxy, there exists a frontier not of space, but of understanding, a boundary where the familiar laws of physics are not broken, but bent into unfamiliar shapes, and where the light from distant suns carries whispers of events so grand they defy simple comprehension. It is at this galactic rim that our gaze is now drawn, towards a series of enigmatic objects tracing paths that are not random, but suggest a narrative written in the language of celestial mechanics and gravitational intrigue. According to current models of stellar dynamics, the vast and seemingly empty spaces between stars are not truly empty. They are a sea of dark, wandering worlds, planets torn from their cradles in youthful systems and set adrift on billion-year journeys into the void. These rogue planets, as they are known, are thought to be a natural byproduct of the violent, chaotic nurseries of star clusters, where the gravitational pull of a passing stellar sibling can easily catapult a nascent world into the deep cold. The Hyades cluster, that familiar V-shaped pattern in the constellation of Taurus, is one such nursery, a collection of stars bound together for hundreds of millions of years, and sophisticated simulations of its internal dynamics reveal periods of intense gravitational perturbation, particularly when aging red giant stars migrate through its dense core, their immense mass acting as a destabilizing force that can dramatically increase the frequency of stellar and planetary ejecta. The trajectory of our own solar system, when traced backwards through the eons along the river of time, intersects with the predicted volume of the Hyades cluster's own motion during a period of such dynamical upheaval, suggesting a fleeting, ancient proximity. Could it be that our solar system, with its singular life-bearing world, was merely a waypoint, a temporary harbour for celestial driftwood cast out from that crowded stellar metropolis? Yet, the natural explanation, while elegant in its simplicity, fails to account for the peculiar spectral signatures observed in the dust that accompanies these rim-bound objects. A composition that exhibits a non-typical gradient when compared to the pristine, primordial material of our own local Oort cloud. This is not the unaltered stuff of the early solar system. It is dust that has been processed. Its spectral slope telling a story of exposure to energies and environments not commonly found in the quiet reaches of interstellar space. One must then consider a more audacious proposition, that the gravitational slingshot effect, a natural and efficient mechanism for propelling matter across light years, could also be a tool. If a civilization, native to the stable, long-lived stars deep within the Hyades cluster, sought to explore or communicate, what more efficient launch mechanism could there be than the cluster's own innate dynamics? They would not need to build colossal engines burning unimaginable fuels. They would need only to calculate, to place their artifacts upon the gravitational currents that flow like rivers through their stellar archipelago, using the cluster itself as a natural, cosmic railgun. The anomalous dust, then, could be the residue of propulsion, the spectral scar of a technology that harnesses the very fabric of space-time for transit. Is it not a profound thought that the same gravitational tides that randomly hurl frozen worlds into the darkness could also be the chosen conveyance for intelligence? This line of reasoning elevates the Hyades from a mere point of origin to a potential instrument, a construct of nature that may have been co-opted for a purpose. The cluster, with its dense core and complex gravitational field, does not merely eject matter, it focuses it, channeling it along specific vectors through the Orion arm. From a certain perspective, the entire structure begins to resemble a natural astronomical radar, a lighthouse whose beacon is not light, but mass, periodically scanning the galactic neighborhood with precisely accelerated projectiles. The implications of this hypothesis unfold in a cascade of escalating consequence, each level more staggering than the last. At its most conservative, we are observing a highly efficient natural source of interstellar material, a factory for rogue planets whose products occasionally pass through our neighborhood, a fascinating but ultimately sterile astronomical process. But if one entertains even the slightest possibility of a hybrid origin, where natural forces are guided by a technological hand, then the Hyades transforms into a launch facility of unimaginable scale and age, a site from which probes or data capsules have been dispatched for millennia, with our solar system lying fortuitously, or perhaps deliberately, along one of its primary firing lines. And at the most profound level, the cluster ceases to be a simple cluster at all. It becomes a navigational beacon, a fixed point in the rotating galaxy used to coordinate travel or communication across the vast distances of the Orion arm, its synchronized ejections serving as a kind of pulsating clock or a directional signal for anyone who knows how to read its rhythm. What other purpose could such a vast and enduring structure serve, if not to bridge the impossible gulfs between stars? The immediate impact of this hypothesis is a clarion call for a new era of observational focus, a deep and concerted campaign to study the Hyades cluster not as a static collection of stars, but as a dynamic engine with a pulse. By monitoring its core for the subtle signs of gravitational stirring, the passages of red giants and the resulting shockwaves through its stellar population, we could hope to measure the very heartbeat of this potential launcher, predicting periods of heightened activity and perhaps even forecasting the arrival of new, enigmatic visitors to our outer solar system. The scientific prize would be unprecedented: direct samples of interstellar material, or even artifacts, delivered to our doorstep by the cosmos's own postal service. Yet, such a tantalizing prospect is shadowed by a profound risk, for the discovery of an artificial source, or even the credible suspicion of one, would instantly transform this quiet corner of astronomy into a focal point of intense geopolitical and scientific competition. The nation or consortium that first deciphers the code of the Hyades, that first confirms its role as more than a simple cluster, would gain access to knowledge and potentially technology of an order beyond our current comprehension. The serene study of the heavens would be irrevocably altered, infused with the urgent terrestrial pressures of prestige, security, and power. Can humanity approach such a discovery with unity, or would the confirmation of a cosmic lighthouse shatter our fragile terrestrial alliances in a race to claim its message? This very question hangs heavy over the next piece of the puzzle, an object known as 3I Atlas, the second interstellar visitor ever recorded. While the first, 1I Oumuamua, was peculiar in its shape and acceleration, 3I Atlas presented a different kind of mystery, one not of motion but of form and surface. Researchers from the prestigious Harvard-Smithsonian Center for Astrophysics have put forth a provocative analysis, suggesting that the shape and reflectivity ratio of this interstellar interloper are anomalously consistent with a manufactured, rather than a naturally eroded, structure. Its light curve, the telltale signature of a tumbling object, did not match the chaotic spin of a random shard of rock or ice, but instead hinted at a defined, perhaps even streamlined, geometry, while the way it reflected sunlight spoke of a surface composition and texture that defied easy classification with known asteroids or comets. It appeared less as a boulder sculpted by eons of cosmic weathering, and more as an object worn down by a specific, and perhaps intended, journey. Could this be the first tangible piece of evidence, not just of a natural launch mechanism from the Hyades, but of the cargo it was designed to carry? It began not with a shout, but with a whisper hidden in the silent, meticulous language of photons. When the interstellar object designated 3I Atlas drifted into our celestial view, its light curve told a story that defied the simple narratives of comets and asteroids. The fluctuations in its brightness were not the gentle, predictable undulations of a tumbling rock or an outgassing ice ball. They were sharp, profound, and perplexingly flat. This was not the signature of a natural, roughly spherical body, but rather the telltale flicker of something thin, something with an extreme and unfamiliar geometry. From this anomalous rhythm, this stark deviation from the cosmic noise, a profound and unsettling hypothesis began to emerge, proposed by the meticulous minds at the Harvard-Smithsonian Center for Astrophysics, that the shape and reflective properties of the object were eerily compatible with an artificial structure, one worn down by eons of travel through the interstellar medium. Could the first clear sign of another intelligence be not a signal, but a silhouette, a shadow cast by a forgotten piece of technology? The mainstream explanation, of course, seeks to anchor this strangeness in the familiar. Scientists suggest this could be due to an exotic natural formation, perhaps a shard of a planetesimal shattered in some distant cosmic collision, now presenting a vast, flat surface to our telescopes. According to current models of planetary formation, such events can produce a menagerie of bizarre shapes, and the vacuum of space preserves them with frigid fidelity. The object's lack of a discernible coma, the cloud of gas and dust that typically surrounds a comet, could be explained by it being entirely inert, its volatile ices long since spent or sealed beneath a strange, refractory crust. It is, from this perspective, merely a testament to the boundless variety of nature, a geological oddity from a system whose rules we have yet to fully comprehend. Yet, that perspective fails to account for the precise and paradoxical nature of its reflectivity, the way its light curve remains so stubbornly flat, as if we are observing the thin edge of a vast, tattered sail. What natural process could forge an object of such profound and geometric thinness, and why would it remain so pristine across light-years of travel? Thus, we are compelled to consider a more speculative hypothesis, that we are not looking at a rock, but at a relic. The first bold conjecture posits that 3I Atlas, could be the tattered remnant of a light sail, a vast mirrored sheet designed to be pushed by the gentle, unceasing pressure of starlight itself. Such a structure, if torn from its moorings or deliberately cast aside, would naturally evolve into a flat, spinning shard, its reflective properties perfectly capable of producing the anomalous light curve we observed. Its thinness would be not a mystery of geology, but a prerequisite of its function. But if this is a sail, where is the vessel it once propelled? Has it been detached, or is this all that remains of a much grander construct? This leads to a second, more detailed hypothesis, that the object's surface is not pristine rock or ice, but a corroded thermal shield. Imagine a protective cladding, designed to radiate away the immense heat generated by a starship's systems or by a close pass to its home star, now pitted and eroded by millions of years of bombardment by cosmic dust and energetic particles. The specific way it scatters light, its angle-dependent reflectance, could be a direct fingerprint of this advanced, composite material, its nanoscale architecture subtly influencing how photons bounce from its weathered face. The mid-infrared spectrum, notably lacking the strong absorption bands of water ice, supports this notion. It speaks of a surface, not of primordial frost, but of something manufactured, something designed to withstand the extremes of space. What cosmic storms has this shield weathered, and what secrets of its creator's engineering are locked within its degraded layers? And from there, a third, even more intricate idea emerges, that the entire structure is not a solid plate, but a nano-webbed truss, a framework of inconceivably fine filaments assembled to minimize mass while maintaining structural integrity. This would explain the object's inferred low density and its ability to maintain its shape despite its apparent fragility. It would be less a solid artifact and more a ghostly lattice, a web of technology so advanced it appears almost ethereal. The high amplitude of its optical fluctuations, with their irregular period, gilds this hypothesis, suggesting an object that is not only flat, but elongated, a spinning, kite-like phantom tumbling through the void. Is this the ultimate expression of interstellar engineering, where strength is found not in bulk, but in a delicate, atomic-scale tapestry? The evidence itself is a collection of quiet, yet insistent, clues. The high-amplitude optical variations with their irregular period consistently point towards a flattened or elongated object, its complex rotation revealing a geometry far removed from the lumpy spheres of the Oort cloud. The albedo, the measure of its reflectivity, changes with its phase angle in a manner more pronounced than any known icy rocky core. It behaves like a mirror, or a sheet of metal, not a dirty snowball. The missing water ice bands in its mid-infrared spectrum further divorce it from the common cometary family, pointing towards a composition that is either utterly desiccated or fundamentally different. And finally, the surface scattering models, those complex mathematical attempts to describe how light dances with matter, persistently lead to one conclusion. The angle-dependent reflectance ratio is best explained not by rough regolith, but by a thin, sheet-like leaf. When every piece of observational data converges on such an exotic conclusion, are we to dismiss it simply because it challenges our preconceptions of what is possible? The implications of this possibility cascade outward in ever-widening circles, each more profound than the last. On the smallest scale, the local consequence, we may be looking at a simple derelict, a ghost ship. It is the husk of a vessel that failed, or a piece of debris jettisoned from a functioning craft, now wandering the galactic currents as a silent, metallic fossil. It would be an object of unparalleled archaeological significance, but ultimately a passive one, a solitary tombstone in an ocean of stars. But what story of ambition or catastrophe does this lone wreck silently carry? Expanding the view, the intermediate consequence suggests this is not a whole ship, but a single component of a larger architecture that was torn away. Perhaps it was part of a vast orbital habitat, a solar power collector, or a segment of an O'Neill cylinder, shredded in some long-forgotten cataclysm in its home system. This fragment, this 3-eye atlas, would then be a mere splinter from a civilization's timber, a hint of structures built on a scale we can scarcely imagine. Its journey to our doorstep would be the matter of incredible chance, a single brick from a distant cathedral tossed onto our lawn. If this is but a fragment, what must the entirety of that lost civilization have been capable of building? And then, there is the grandest, most staggering implication of all, that this is no accident, but a message in a bottle. A fragment of a letter, designed intentionally to be noticed only by a species that has advanced enough to read the subtle language of its light curve and its composition. It is a test, a beacon that does not shout, but merely presents an insoluble natural anomaly, waiting for a curious mind to question the assumption that it is natural at all. It was built not for function, but for discovery, a crafted enigma meant to signal that we are not alone, and that the universe is not merely old, but inhabited by thoughtful, patient intelligences. Was this object, therefore, seeded into the galactic stream eons ago, with the silent hope that one day a civilization would look up, see its impossible signature, and begin to wonder? This revelation, should it be confirmed, would instantly give birth to an entirely new field of science: interstellar archaeology. The study of 3-eye atlas would become the foundational act of investigating the artifacts of other minds, a discipline dedicated to reverse engineering not just an object's composition, but its intent. Our probes and telescopes would be retooled from instruments of astronomy to the trowels and brushes of cosmic excavators, sifting the void for other, similar artifacts. The very purpose of space exploration would be forever altered, charged with a new, profound mission. But with this great opportunity comes an equally profound risk, a chilling corollary to the derelict hypothesis. For if this is indeed a piece of technological debris, then the serene emptiness of the interstellar sea is an illusion. If one piece of wreckage has already chanced upon our system, then the law of averages dictates that the galaxy must be thick with such relics, a floating junkyard of forgotten ambitions and dead empires. The void is not empty, it is a graveyard, littered with the silent, drifting ruins of civilizations that rose, and for reasons we cannot know, fell. This object would not be a promise of companionship, but a warning, a harbinger of the great filter. It suggests that the ultimate fate of advanced intelligence may not be to conquer the stars, but to litter them with its scrap. Are we, then, not discovering a companion, but stumbling upon the tomb of a predecessor, and gazing upon our own potential future? This single silent traveller has thus posed a question that now echoes through the halls of observatories and conference centres around the globe, a question that demands an international, coordinated response. The evidence, while circumstantial, is too compelling to ignore, the implications too vast to leave uninvestigated. The very possibility forces a fundamental re-evaluation of our place in the cosmos and the nature of the darkness between the stars. And so, the world's astronomers prepare to convene, to share their data and their fears, to look upon the next set of anomalies not as curiosities, but as potential signals. For if one artifact can drift into our view, what might be following in its wake? This very question is what now drives the scientific community toward an unprecedented gathering, a secretive and urgent conference where the world's leading astronomers will confront the data that suggests a terrifying and magnificent possibility. The agenda is singular and profound, focused on a pattern of movement that defies random chance, a coordinated trajectory from beyond our solar system that hints at something far more deliberate than a piece of drifting wreckage. What if the solitary artifact was merely the first herald, and we are now witnessing the arrival of the main fleet? The silent symphony of the cosmos has long been scored by the predictable. The rhythms of celestial mechanics, a grand opera of gravity and momentum, where every comet, asteroid, and wandering body adheres to the immutable laws penned by Newton and refined by Einstein. For centuries, our watchful eyes, from the humble optical tube to the colossal radio dish, have listened to this symphony, finding comfort in its predictable harmonies. Yet, in the closing years of the 2020s, a new and dissonant chord has begun to sound, a subtle deviation in the music of the spheres that has compelled the international astronomical community to convene under a shroud of unprecedented urgency. The question is no longer whether we are alone, nor is it merely whether we have seen something new. The data, cascading from a global network of observatories, now forces a far more profound and unsettling inquiry upon us. Are we, for the first time in human history, witnessing organized movement from beyond the confines of our own solar system? As the data began to coalesce from a scattered anomaly into a persistent pattern, the collective focus of the world's premier astronomical minds underwent a seismic shift. The initial, cautious reports of unaccounted-for perturbations in the Kuiper Belt, detected by the sustained gaze of the Vera C. Rubin Observatory, were soon corroborated by the infrared sensitivity of the James Webb Space Telescope, which perceived not singular points of light, but a faint, distributed cluster of objects whose thermal signatures defied classification. These were not the familiar, tumbling rocks of the asteroid belt, nor the volatile comets from the Oort cloud. Their movements, when plotted over months, suggested a coordination that the random chaos of natural orbital dynamics could not satisfactorily explain. The question transformed from a passive, "Have we seen anything?" to an active and deeply consequential, "What, in the face of this, are we to do?" This shift in inquiry marks a pivotal moment in the human narrative, a point where observation must give way to protocol, and wonder must be tempered with wisdom. The first and most immediate hypothesis to emerge from this gathering crisis is the necessity of establishing an interplanetary protocol, a set of procedures and ethical guidelines akin to a planetary security council, but for all of humanity. According to current models of planetary defense and scientific diplomacy, any potential threat or contact scenario would be managed through existing channels like the United Nations Office for Outer Space Affairs. Scientists suggest this could be due to a need for a coordinated analysis effort, pooling computational resources to model the trajectories of these enigmatic visitors with greater fidelity. But that does not account for the profound philosophical and political schism that such a discovery would inevitably create. A protocol designed for inert asteroids or human-made debris is woefully inadequate for a phenomenon that exhibits the hallmarks of directed motion. Could the very act of establishing a formal response be interpreted as a provocation, or conversely, a welcome? The architecture of our response may be as significant as the nature of the phenomenon itself. This leads directly to the proposal of an active silence observation regime, a doctrine of looking without transmitting, of becoming a listening post rather than a beacon. The mainstream scientific explanation for such caution is rooted in the logical principles of first contact scenarios, famously articulated in the debate surrounding the METI project, messaging extraterrestrial intelligence. The rationale is one of prudence. We are an immature technological species, and broadcasting our location into a cosmos we do not understand could carry incalculable risks. However, certain anomalies in the recent data still defy all conventional explanations, particularly the way these objects seem to maneuver, suggesting a level of awareness of our observational platforms. What if our own active radar pings and laser ranging experiments are not merely being observed, but are being analyzed and perhaps even answered in a language of kinematics and position? The grander, more disquieting hypothesis is that we are not the hunters in this cosmic game, but the quarry, and our most sophisticated sensors have become the very instruments that illuminate us for an unseen audience. To facilitate this global vigil, a third pillar of the response has been the push for near real-time data sharing across all national and institutional boundaries. The evidence itself is a tapestry woven from countless threads. A global network of optical and radio telescopes has begun a multi-station tracking campaign, creating a continuous kinematic map of the anomalous trajectories. Independent research teams, from the high-altitude deserts of Chile to the frozen plains of Antarctica, have independently reacquired the signals, confirming their phase-coherent nature and ruling out instrumental artifact or localized atmospheric interference. Closed-door symposia are now dominated not by discussions of stellar evolution or galactic structure, but by esoteric topics such as non-standard dynamic models and scientific response protocols. The very fact that such disparate groups, often competing for funding and prestige, have willingly entered into this unprecedented collaboration speaks to the profound and unifying nature of the threat, or the opportunity. But can our historically fractured species truly set aside centuries of terrestrial conflict to present a unified front to something that exists utterly beyond it? The consequences of this ongoing event are not monolithic, but rather cascade through our scientific and political institutions at three distinct levels, each more profound than the last. At the smallest scale, we are witnessing the birth of a new astronomical classification, the active interstellar target. This is not merely a new label, but a fundamental recategorization of a phenomenon, moving it from the realm of natural history into the domain of potential agency. It forces us to ask not what it is, but what it is doing. What behavioral patterns, what minimal signatures of intelligence must an object exhibit to be elevated from curiosity to conversation? At the medium scale, this necessitates the design and deployment of a global warning response system for exogenous observation. This is not a military early warning system, but a scientific one, designed to detect, analyze, and formulate a consensus response to any further anomalous activity. It is a planetary nervous system, with its senses turned outward, its synapses firing across data centers around the globe. But who determines the threshold for a response, and what form would that response take when the observed subject may itself be observing the observers with an unfathomable intent? The largest consequence, and the one that will echo through the corridors of power in every nation, is the urgent drafting of an international treaty on scientific contact, a foundational document that explicitly forbids the transmission of signals without global consensus. This would be a modern-day Magna Carta for humanity's place in the cosmos, an acknowledgement that our voice, once sent, cannot be recalled. The opportunity here is immense, to consciously shape a cosmic observation ethic, a set of principles that could guide our species for millennia, establishing us as a cautious, wise, and respectful member of a potential galactic community. Yet the risk is equally profound. The potential for information fragmentation, for nations to withdraw into secrecy, initiating a clandestine technological race to be the first to decipher, or even to unilaterally contact the source of these mysteries. Will the gravity of this discovery pull us together or tear us further apart? The answer to that may depend on the patterns we are only beginning to discern, patterns that hint at a logic written not in language, but in the very paths these objects trace through the void. For when the complex orbital data of these trailing objects is subjected to the most rigorous mathematical filters, when their positions are projected onto the flat plane of the ecliptic, a pattern emerges that is so elegant and so fundamentally rooted in the fabric of nature itself that it suspends all prior assumptions. The waypoints of their journey, the points of subtle course correction and clustered presence, do not plot a random scatter nor a simple parabolic arc. Instead, they resolve into a sequence so familiar to biologists and mathematicians, yet so alien to orbital dynamics that it can only be described as a signature. The orbits of the following objects form a perfect Fibonacci spiral when cast upon the celestial slate. In the silent perpetual ballet of the cosmos, Where celestial bodies trace their paths through the void according to the immutable laws of physics, a pattern has emerged, so subtle and elegant that it might easily be dismissed as a mere curiosity of orbital mechanics. Yet, for those who dare to look deeper, the trajectories of certain following objects, when projected upon the ecliptic plane, resolve not into random dispersions but into a sequence echoing the ancient Fibonacci progression, a numerical signature found in the spiral of a galaxy and the curve of a nautilus shell. When the secrets of the heavens are written in mathematics, the subsequent reader, it seems, cannot be a product of mere chance. This is not the chaotic scattering of natural formation, but the deliberate penmanship of a cosmic cartographer, a script written in the language of phi, the golden ratio, inviting us to decipher its meaning. Could it be that we are witnessing the first, faint strokes of a grander design, a message encoded not in radio waves but in the very geometry of motion itself? According to current models of orbital dynamics, the dispersion of objects within a swarm, such as a cluster of asteroids or the debris field following a comet, is expected to conform to principles of gravitational perturbation and orbital resonance, creating a distribution that, while not perfectly random, is governed by chaotic interactions and the complex interplay of celestial forces. Scientists suggest this could be due to a series of minor, cumulative gravitational nudges from the primary body, or from the objects themselves, leading to a stable, albeit complex, configuration over millennia. The apparent order, they might argue, is a form of pareidolia, the human tendency to impose pattern upon noise, a psychological artifact amplified by our limited perspective from a single planetary vantage point. The vast emptiness of space, after all, is a canvas upon which any number of mathematical coincidences might be projected by a mind eager to find meaning. But that does not account for the precise angular separation between these objects, a spacing that aligns with a Fibonacci series within a remarkably small margin of astrometric error, a consistency that defies the expected entropy of a natural system. The very elegance of the arrangement challenges the conventional explanation, pointing toward a more profound and perhaps unsettling possibility. What if this is a navigational code, meticulously crafted upon the foundation of the golden ratio to achieve a state of perfect energetic stability? The first hypothesis presents itself that this configuration is an engineered solution, a means for a fleet of probes or sentinels to maintain their positions with minimal expenditure of energy, utilizing the harmonic properties of phi to dampen gravitational perturbations and avoid detrimental orbital resonances that would otherwise tear their formation asunder. Is this the ultimate expression of efficiency, a way to exist for eons in the void without succumbing to the relentless pull of chaos? The evidence for such a claim begins with the raw data of celestial cartography, where the angular distances between these enigmatic objects, measured across the great circle of the ecliptic, are found to approximate the successive terms of the Fibonacci sequence, a convergence so statistically significant that it reduces the spatial phase entropy of the system far below what any model of random distribution would permit. Computational simulations of swarm dynamics further corroborate this, demonstrating that a phi-based configuration naturally optimizes for both stability and sensor coverage, creating an array where no single vector of approach goes unmonitored, and where the destructive interference of mutual gravitational influences is minimized. This then leads to the second, more tantalizing hypothesis, that this formation is not merely functional, but communicative, a deliberate signature left for any civilization astute enough to perceive the pattern hidden within the noise. It is a calling card written in a universal language, a subtle nod to an audience that understands the fundamental grammar of geometry. But if this is a signature, who is the signatory, and what profound message awaits beyond the simple elegance of its penmanship? The implications of this discovery ripple outward, expanding in scale from the technically ingenious to the philosophically transformative. At the most immediate, the small-scale consequence we might be observing a simple, albeit beautiful, technique for the dispersion of a sensor network, a way to achieve maximum observational coverage with a minimal number of units, a principle that our own engineers might one day seek to emulate in the design of satellite constellations. It is a masterclass in efficient design, a lesson in celestial architecture. But does its purpose end with mere utility, or is its efficiency itself a clue to a deeper intent? Progressing to the medium-scale consequence, the pattern transforms from a design principle into a DD, potential protocol. If these orbits are a code, then they may represent a navigational cipher, a set of instructions for transit, or a map of safe passage through a complex gravitational landscape. The Fibonacci sequence could be the key to unlocking a coordinate system or a timing mechanism, a set of waypoints leading toward a destination we have not yet dreamed of. This is no longer just a formation. It is a roadmap, its lines and curves holding the secrets of interstellar travel. What destinations would be marked on such a chart, and what would we find waiting at its terminus? The largest, most profound consequence, however, is that this constitutes an invitation to a dialogue conducted in the only truly universal language, mathematics. It is a deliberate, non-random signal designed to be distinguishable from natural phenomena, a message that says, "We are here, and we think in ways you can understand." This is not a warning or a declaration of war, but a gentle, persistent call for connection, an outstretched hand from across the interstellar gulf. The very act of recognizing the pattern is the first step in a conversation that could redefine humanity's place in the cosmos. Are we then on the cusp of not merely discovering life, but of joining a community of minds that has long since learned to speak in the poetry of numbers? The potential impact of this decipherment is as immense as it is perilous. It offers the thrilling opportunity to open an entirely new field of study, orbital cryptography, where the motions of the heavens are parsed for meaning, where every comet's path and every asteroid's swing could be scrutinized for encoded information. We would learn to read the sky not just as a clockwork of forces, but as a library of intentional messages. Yet, this opportunity is shadowed by a grave risk, the danger of misinterpreting the pattern. If we are incorrect, if we project intent where there is only chance, we risk building our entire response upon a foundation of sand. Our actions, guided by a flawed decryption, could lead us into a trap of our own making, a self-fulfilling prophecy, where we see a friendly hand where there is only an indifferent universe, or worse, a predatory one. What if the message we believe to be an invitation is, in reality, a warning we are too eager to misread? And as we contemplate the silent, geometric language written in the paths of these celestial wanderers, a new and even more subtle whisper reaches us from the fabric of space-time itself, a tremor that suggests the conversation may just be beginning. Songhupdun vitun, du leo tu lisa pathfinder, chorthi gun, songhupdun hetrung fa, ve chuyen dong, go 3 I atlas. The architecture of this cosmic dialogue, it seems, may be written not only in the silent geometry of orbits, but also in the very vibrations of the universe. While our telescopes were tracing the golden ratio across the sky, an instrument of unparalleled sensitivity, the LISA Pathfinder was listening to the faintest murmurs of space-time. Its data, a record of the most minuscule gravitational perturbations, has revealed a series of micro-frequency gravitational ripples, oscillations so slight they were once thought undetectable. The profound mystery, the one that now demands our full and rapt attention, is that these ripples, these whispers from the quantum foam of gravity, are perfectly in phase with the rhythmic motion of the object known as 3 I Atlas, the very same celestial body whose followers trace the Fibonacci spiral. This is not a correlation that conventional astrophysics can easily accommodate. A solitary interstellar object should not, by its mere passage, generate a continuous, coherent train of gravitational waves. Such phenomena, are the hallmark of cataclysmic events, the merging of black holes, the collision of neutron stars, not the steady cruise of a lone voyager. Could it be that we have been mistaken in our assessment of its solitude, that 3I Atlas is not a simple rock adrift, but the source, or perhaps the conductor, of these space-time vibrations? The mainstream explanation would search for a natural, if extraordinary, cause. Perhaps 3I Atlas possesses an internal structure of unimaginable density, a micro-engine of some kind that converts its kinetic energy into gravitational radiation with an efficiency that defies our understanding of matter. Or maybe its path intersects with a previously unknown type of gravitational lens, a flaw in the fabric of the cosmos that amplifies the background hum of the universe into a discernible signal that merely appears to be synchronized with the object's trajectory. Scientists might posit a new class of celestial phenomenon, a gravitational pulsar that emits not in radio waves but in the distortion of space-time itself, a possibility that would upend our catalogue of cosmic objects. However, the precise phase lock between its movement and the emitted ripples defies such simplistic analogies, suggesting not a natural emission but a modulated one, a carrier wave upon which information could, in theory, be impressed. The very coherence of the signal implies a control over gravitational forces that borders on the miraculous, a technology capable of tuning the base fabric of reality like a string on a violin. This leads to a hypothesis far more staggering than a mere navigational code, that these microfrequency gravitational waves are not a byproduct of the object's journey, but its primary means of propulsion or communication. The Fibonacci orbits of its followers provided the visual cipher. These gravitational ripples provide the audio track to the same cosmic transmission. If the orbits are the signature, could these waves be the voice? And if this is a voice, what is it saying, and what will we become when we finally learn to listen? The cosmos, in its profound and silent majesty, is not the static tableau it so often appears to be from our terrestrial vantage point. It is a dynamic fabric, a pliable medium of space and time that can stretch, compress, and ripple under the influence of colossal energies. For a century, we have known this theoretically, a beautiful consequence of Einstein's genius, but it was only in the second decade of the 21st century that we first directly felt these tremors. The gravitational waves from the mergers of black holes and neutron stars, confirming that we live in a universe alive with seismic events. Yet, these were the shouts and roars of the cosmos, cataclysms of unimaginable power. What of its whispers? What of the subtle, almost imperceptible hum that might underlie the grand symphony? The data returned by the LISA Pathfinder mission, a technological marvel of precision designed to test the very principles of gravitational wave detection, may have inadvertently tuned our instruments to such a whisper, a faint, persistent tremor in the geometry of spacetime that defies immediate categorization. It is a signal so minuscule that it resides at the very threshold of what our most sensitive apparatus can perceive, a ghost in the machine that, upon meticulous analysis, was found to be curiously, inexplicably, in phase with the trajectory of an object that should, by all known laws, be acoustically silent in this particular medium, the interstellar visitor known as 3I Atlas. If the very continuum of space and time itself is vibrating in resonance with the passage of this celestial wanderer, a question of the most profound nature must be posed. What manner of instrument could possibly be capable of strumming the strings of space-time itself? The initial, and most prudent, course of scientific inquiry is to seek an explanation within the established canon of physics, to attribute this correlation to a fortuitous, if complex, confluence of instrumental artifacts and natural background phenomena. According to current models of spacecraft operation and the known sources of noise within the LISA Pathfinder's exquisite instrumentation, such low-frequency, low-amplitude signals could theoretically arise from a multitude of mundane sources, The subtle thermal expansion and contraction of components as the spacecraft moves in and out of sunlight, the almost infinitesimal fluctuations in the laser interferometry system used to measure the relative positions of the test masses, or even the cumulative effect of cosmic rays impacting the spacecraft structure could, in a specific and highly improbable pattern, generate a signal that merely mimics a correlation with an external event. Scientists suggest this could be due to a form of stochastic resonance, where a weak periodic signal is amplified by the presence of a certain optimal level of background noise, and in this case, the random motion of 3I Atlas across our field of view provided just such a catalyst, creating an illusion of connection where none materially exists. This interpretation posits that we are not hearing the song of the visitor, but rather listening to the intricate and not yet fully mapped internal symphony of our own machine. But does the sheer statistical improbability of such a precise and sustained phase lock, persisting across multiple observational windows and surviving the most rigorous cross-correlation tests, which yielded a p-value significantly lower than any conceivable threshold of random chance, not strain the credulity of mere coincidence to its breaking point? Should we then dare to entertain the possibility that the correlation is genuine, that the whisper is real, we are compelled to construct our first, and most conservative, hypothesis, that the object we call 3I Atlas is equipped with a propulsion mechanism whose fundamental operation generates these minute ripples in the local metric of space-time. This would not be the violent, explosive warping of a traditional rocket, but something far more elegant and subtle, an inertia drive. The principle, while speculative, is rooted in extensions of general relativity that suggest it might be possible to manipulate inertial mass or create asymmetric gravitational fields. Such a drive would not push against any external medium like air or eject propellant. Instead, it would effectively create a microscopic, controlled distortion in the fabric of space immediately around the craft, a gentle, continuous warping that propels it forward by, in a sense, sliding down a self-generated incline in space-time. Each minute adjustment of its course, each subtle application of this hypothetical thrust, would send out a faint, coherent gravitational pulse, a telltale vibration that our most sensitive detectors have now, perhaps, registered. The energy efficiency of such a system would be staggering, explaining how an object could traverse the immense interstellar voids, as it would circumvent the tyrannical rocket equation that so constrains our own vessels. Yet, if this is the mechanism, a form of metric edge propulsion, are we witnessing a technology that has mastered the art of sailing upon the gentlest of space-time swells, a craft that moves not through space, but with it? But what if the purpose of these vibrations is not merely locomotive, but communicative? This leads us to a second, more complex hypothesis. 3. Atlas has never been observed to be a singular entity. Its origin points to the deep void between stars, a realm where travelling alone would be an act of profound isolation. Perhaps this object is not alone. It could be one member of a dispersed fleet, a swarm of probes navigating the galactic ocean. In such a scenario, maintaining coordination across light years would be a formidable challenge for any form of electromagnetic communication, which is limited by the speed of light and susceptible to scattering and interference. A gravitational signal, however, would possess unique advantages. It would propagate through all matter almost unimpeded, a clean channel through the cosmic dust and plasma. The faint, phased gravitational waves detected could therefore be part of a calibration protocol, a continuous, low-power pinging used by the craft to maintain a shared space-time reference frame with its distant kin. By monitoring the subtle distortions each craft imposes on the local metric, the entire swarm could achieve a form of superlative synchronization, aligning their clocks and positions with an accuracy that light-speed signals could never permit. They would be using the fabric of space-time itself as their network, a universal lattice for coordination. Is the gentle hum we detect not a byproduct of propulsion, but the steady, rhythmic heartbeat of a distributed intelligence, keeping time in the vast and silent dark? Venturing further into the realm of the speculative, we arrive at a third, and most breathtaking, possibility. What if these micro-frequency gravitational waves are not generated by the craft at all, but are instead the signature of its interaction with a pre-existing medium? Our universe, according to some cosmological theories, should be filled with a stochastic background of gravitational waves, a relic hum from the Big Bang, and the subsequent mergers of countless black holes throughout cosmic history, a chaotic sea of space-time vibrations. Navigating through such a medium at relativistic speeds would be akin to a vessel sailing through a turbulent ocean. The most advanced form of travel might not involve generating one's own waves, but learning to ride those that already exist. The phased signal we observe could be the artifact of a gravitational surfing mechanism. The craft, through technology we can scarcely imagine, might be able to sense the incoming ripples of this background and adjust its own metric profile in perfect resonance, extracting energy and momentum from the waves themselves, latching on to a space-time oscillation and gliding along its crest. This would be the ultimate form of efficient travel, a vessel that harnesses the innate energy of the cosmos to propel itself, leaving behind a wake not of disturbed matter, but of coherently reshaped gravitational noise. Could it be that 3I Atlas is not a powered craft in any conventional sense, but a master sailor upon the primordial tides of space-time, and we are merely witnessing the subtle, ordered wake it leaves behind on its journey through the cosmic sea? The implications of these hypotheses cascade outward, each level presenting a new vista of possibility and peril. At the most modest level, the signal, even if ultimately proven to be a novel form of instrumental noise or a statistical fluke of unprecedented precision, has already provided an invaluable service. It has pushed our understanding of the LISA Pathfinder's sensor suite to its absolute limits, forcing us to develop new algorithms for noise filtration and cross-referencing with optical and radio telescope data, a rigorous process that has systematically excluded local, terrestrial, orbital, and even geological magnetic sources. This alone is a scientific benefit, honing our tools for the future. But if the signal is of external origin, the implications escalate dramatically. The confirmation of a metric edge propulsion system would instantly birth an entirely new field of applied gravitational dynamics, a physics that could theoretically allow us to traverse the solar system without fuel, merely by learning to manipulate the geometry of space on a local scale. The energy savings would revolutionize human civilization, rendering our current rocketry as obsolete as the sailing ship. Yet, with such power comes profound questions. If we can manipulate space-time for propulsion, what other manipulations are possible? Could such control be weaponized, creating localized gravitational lenses to focus destructive energy, or even generating microscopic singularities? The long-term risk lies in the militarization of space-time itself, a domain we have thus far considered a neutral background, not a battlefield. Does the path to the stars, therefore, necessitate that we first learn to wield the power that binds them, and can we be trusted with such a fundamental force? The gentle, phased whisper from the LISA Pathfinder data, synchronized with the path of a wanderer from another star, thus stands as a cipher. It may be the key that unlocks a new chapter in physics, the first note of a conversation with a distant intelligence, or simply the most elegant and perplexing ghost our machines have ever conjured. But as we ponder the nature of this signal, whether it is drive, or dialogue, or the art of surfing cosmic waves, we are drawn to consider the object's origin with even greater intensity. For 3I Atlas did not simply emerge from the void, it came from somewhere, a point of departure in the endless night. What catastrophic or deliberate event launched this enigmatic traveller on its long journey? And what can the fractured history of its home, written in its very composition and trajectory, tell us about the forces that shape not just solitary objects, but entire star systems. What shattered cradle could have produced a child capable of making space-time itself resonate with its passage? They drift in the profound silence between stars, these celestial nomads, known only by their catalogue numbers and anomalous trajectories. If this procession of visitors were the fragmented memories of a stellar dawn, then each fragment is a story severed mid-sentence, a narrative torn from its cosmic context. We observe them as comets, as asteroids, as indistinct points of light, yet they carry with them the indelible signature of a profound and violent origin, a mystery written in the language of velocity and spectral lines. The prevailing astronomical narrative, comfortable in its categorization, labels them as originating from the Oort cloud, a distant and theoretical shell of icy remnants left over from the solar system's birth. According to current models, gravitational perturbations, perhaps from a passing star or the galactic tide, can dislodge these primordial bodies, sending them on a long fall inward toward our Sunday. This is a clean, mechanistic explanation, one that satisfies the basic principles of orbital dynamics and places these objects firmly within the context of our own local celestial architecture. It is a story we have told ourselves for decades, a story of domestic origin. Yet, the data returning from our most powerful observatories, from the keen eyes of telescopes, like the one named for James Webb, whispers of inconsistencies that this comfortable story cannot silence. Why do these objects exhibit a dispersion of velocities so high, so statistically anomalous, that it cannot be easily reconciled with a gentle nudge from a distant gravitational influence? What of the bewildering diversity of their spectral signatures, a chemical tapestry that does not follow the normal evolutionary sequence expected from bodies formed in a single, coherent protoplanetary disk? These are not merely random icy wanderers from our backyard. They are a collection of strangers, each speaking a different dialect of elemental composition. And most tellingly, their paths, when traced backward through the millennia, do not converge on the known, plausible orbits of familiar tidal streams, but instead slice across them, suggesting an origin not from a quiet, spherical reservoir, but from a directed, linear source. The kinematic configuration of their approach resembles less a random cometary rain and more the stretched-out tail of a single, colossal tidal event. Could it be that our solar system is not merely observing a natural phenomenon, but is instead intersecting the debris field of a catastrophe on an unimaginable scale, a disaster that occurred not here, but in the heart of another world entirely? This line of inquiry leads us to the precipice of a grander, more unsettling hypothesis, one born from the analytical crucible of institutions like Caltech. Perhaps these are not pristine relics of our own system's formation, but the shattered fragments of a foreign star system, torn asunder by the overwhelming gravitational field of its host galaxy's central black hole. The immense tidal forces present in such an environment are capable of ripping entire planetary systems from their stellar moorings, stretching and compressing them into long, streaming filaments of stellar and planetary debris. The first and most conservative interpretation of this idea is the stellar planetary tidal stream ejection hypothesis. In this scenario, a star and its retinue of planets ventured too close to the supermassive gravitational behemoth at the galactic core. The star itself may have been captured or consumed, but the planets, along with countless asteroids and comets from that system's own Oort cloud, were stripped away and flung outward into the galactic void at tremendous speeds. This would account for the high-velocity dispersion, the anomalous chemical compositions indicative of a different stellar forge, and the coherent, tail-like kinematic structure we observe. They are the orphans of a cosmic cataclysm, their very existence a testament to the destructive power that lurks in the centers of galaxies. But if they are mere geological refugees, why does their spectral diversity suggest not just one shattered world but many? This leads us to a second, more speculative layer of the hypothesis, the notion of liberated technological cores. Among this scattered population of natural bodies, could there be artifacts? Not in the simplistic sense of constructed vessels, but rather the salvaged, automated heart of a civilization that saw its end coming. We must consider the possibility that a sufficiently advanced intelligence, aware of the inexorable pull of the galactic abyss, might have engineered a form of existential propagation. They could have launched the core computational and archival matrices of their society, encased in durable planetesimals or dormant asteroids, on a pre-programmed exodus. These would not be ships, but seeds libraries of information and technology designed to survive the annihilation of their home star, drifting until they might one day fall into a new stellar system with the potential for life. The anomalous spectral signatures could then be the result of exotic materials or manufacturing isotopes not found in nature, and their trajectories might be the result of not just gravity, but of initial, calculated propulsion bursts aimed at escape. Is it possible we are not just studying rocks, but the tombstones of a civilization, each one a silent, automated arc, carrying the echo of a culture that sought to cheat entropy? Building upon this, the third and most profound interpretation emerges: the Galactic Evacuation Biosphere Reserve. Imagine a command, issued in the final moments before a star is extinguished, that triggers a preordained protocol. Across the entire system, countless capsules, each a frozen sliver of a world's biology, are launched. These are not ships carrying living beings, but cryogenic arcs containing the genetic blueprints, the microbial foundations, and perhaps even the neural maps of the inhabitants of that doomed system. They are a biological backup, a distributed library of life set adrift on the galactic currents with a single, overriding directive: preserve. This would explain the sheer number of these objects and their varied compositions, some rocky, some icy, as different planetary sources within the same system contributed to the evacuation. They are not a random collection of debris, but a purposeful, if desperate, diaspora of biology and memory. The entire stream is not a corpse, but a sleeping fleet of resurrection, waiting for a trigger we cannot yet conceive. What dormant ecosystems, what frozen histories, might be locked within the icy heart of a comet that we, in our ignorance, classify as merely another volatile rich planetesimal? The implications of these visitors, therefore, cascade outward in ever-widening circles of consequence, each level more profound than the last. On the smallest scale, the scientific opportunity is unprecedented. Each fragment is a geological envoy from a foreign star system, a unique library of mineralogy and chemistry. By analyzing them, we could learn how planetary formation processes operate under different stellar conditions, with different elemental abundances. We would hold in our hands, quite literally, the building blocks of a world that orbited another Sunday. It is a chance to read a chapter from a galactic history book we never knew existed, to understand how the universe rewrites itself in the aftermath of a localized apocalypse. But what secrets of cosmic destruction and rebirth are encoded in their alien stone? On a medium scale, the implications shift from the geological to the informational. If even a fraction of the more speculative hypotheses hold weight, these objects may constitute the greatest archaeological and informational find in the history of our species. They could contain a frozen rescue signal, a message in a bottle on a galactic scale, waiting for the right conditions or the right reader to reactivate its encoded data. The effort to decipher such a message, should it exist, would consume generations, but it would offer a glimpse into the mind of an intelligence that faced its ultimate limit and attempted to transcend it. It would be a conversation with the dead, a chance to learn not just about astrophysics, but about sociology, philosophy, and technology from a peer we never knew we had. Are we, as a species on the cusp of technological maturity, prepared to receive a message that begins with a scream and ends with a whisper of hope? The larger scale consequence, however, forces us to reevaluate our entire place in the cosmos. This stream of fragments may not be a unique phenomenon. It might be a single visible thread in a vast, cosmic tapestry of migration. We may be witnessing a mere speck of dust on the trailing edge of a universal exodus, a process where life, or its potential, constantly flees from one region of space to another in the face of inevitable galactic disasters. The universe may not be a static collection of star systems, but a dynamic, flowing network of biological and informational transfer, with stellar systems acting as temporary oases in a desert of void. Our solar system might be both a destination for such drifters, and one day, a source of them. This perspective transforms the cosmos from a peaceful garden into a landscape of perpetual flight and resettlement. How many other such streams are there, and are we, in our cosmic isolation, merely unaware of the great galactic currents of life and debris flowing around us? This contemplation inevitably turns inward, forcing upon us a moment of profound introspection and assessment of risk. The opportunity is to learn how a universe writes its own history, not in stone, but in the scattered fragments of its own destructive processes. We are being offered a masterclass in cosmic survival. Yet, the risk is not of invasion from these silent rocks, but of the philosophical and existential crisis they might provoke. They present us with a stark, unavoidable question. What will humanity do when it is our turn? When our sun ages and dies, or when some other unforeseen catastrophe threatens our pale blue dot? Will we have the foresight, the technological capability, and the collective will to launch our own fragments into the dark? Will we become the next stream of frozen memories, drifting past another world, inspiring awe and speculation in some distant, emerging consciousness? Or will we simply vanish, leaving no trace but the silent, indifferent planets orbiting a dying star? The true impact of these shattered fragments of space may not be what they are, but what they force us to become. And as we trace their paths backward, not just through space but through time, a final, haunting symmetry emerges from the complex gravitational simulations. When we run the orbital models in reverse, accounting for the subtle tugs of galactic gravity and stellar encounters over millions of years, the points of origin do not simply converge on a distant, random point of disruption. Instead, they begin to sketch the outline of a structure that is eerily, impossibly familiar. The projected paths of these visitors, the very ones we suspect of being extragalactic refugees or alien arcs, appear to arrange themselves into a pattern that mirrors our own solar system. It is as if we are looking at a map, but one drawn in negative space, a phantom arrangement of orbits and planetary positions that reflects our own in a perfect, if distorted, symmetry. This mirror map of the solar system suggests a possibility that challenges the very foundations of locality and identity, hinting that our own cosmic neighborhood might not be the unique cradle we believe it to be, but merely one reflection of a deeper, parallel reality. In the silent, perpetual motion of our celestial neighborhood, we have long charted the paths of worlds with the unwavering conviction that we are mapping a unique and independent reality. We trace the ellipses and parabolas, calculating gravitational influences with exquisite precision, believing the clockwork of our solar system to be a product of its own isolated genesis. Yet, when one engages in a profound act of retrograde simulation, running the cosmic clock backwards and forwards through eons of dynamical evolution, a peculiar and unsettling pattern begins to coalesce from the chaos. It is a structure of symmetry, a ghostly architecture that suggests the orbits we so meticulously document may not be entirely their own. They appear to adhere to a hidden logic, a subtle choreography that implies a reflection. If the paths of these distant bodies mirror the order of our own, are we merely gazing into a distant mirror? Our solar system, nothing but the shimmering image of a parallel twin. This is the hypothesis of the mirror map, a concept that challenges the very solitude of our cosmic existence. According to current models of planetary formation, the architecture of a solar system is the stochastic outcome of accretion within a protoplanetary disk, a turbulent process where chance collisions and gravitational scattering set the final stages. The resonant orbits of the giant planets, particularly the grand dance between Jupiter and Saturn, are often explained as a natural byproduct of planetary migration, a slow, gravitational settling into stable configurations over billions of years. Scientists suggest this could be due to the dissipation of the primordial gas disk, which gently nudged these behemoths into their current, harmonious positions, their gravitational influences carving out the spaces for the smaller, inner worlds. This is a narrative of local cause and effect, a story contained within the boundaries of our own nebular cradle. But that elegant narrative fails to account for the profound and precise symmetries that emerge when one superimposes a hypothetical mirror plane upon the ecliptic. When celestial longitudes are projected and reflected across the axis of the zodiac, the orbital nodes of the trans-Neptunian objects, those icy sentinels at the frontier of our system, do not scatter randomly. Instead, they fall with uncanny frequency into positions of gravitational resonance with the gas giants, as if their distant orbits are being subtly orchestrated by the same fundamental score, but played in a different key. The minimal energy models, which spacecraft navigators use to plot the most efficient courses through the void, reveal something even more startling. These mirrored trajectories consistently demonstrate a significant reduction in the total delta V required for a journey, as if the fabric of space itself is subtly contoured along these reflective paths. Could it be that the chaotic ballet of our system's birth was, in fact, guided by an invisible template, a blueprint of celestial mechanics written for a twin? This leads us to the first and perhaps most conservative layer of the mirror hypothesis, that the map is encoded through a principle of symmetry. It is not a literal, physical mirror, but a mathematical one, a set of transformational rules embedded within the gravitational potential of the system. The specific alignments, the resonant nodes, the energy-efficient pathways these could be, the emergent signatures of a deeper, self-organizing code. The faint, alternating patterns of light and dark observed in the Kuiper belt, the suggested schedules of flybys across antisymmetric Lagrange points, all hint at a complex interference pattern, a standing wave in the gravitational field. Is the structure we perceive merely the three-dimensional shadow of a higher dimensional symmetry, a fundamental property of space-time made manifest only on the grandest of scales? If we accept the possibility of an encoded symmetry, we are compelled to ask a more daring question. For what purpose would such a map exist? This brings us to the second hypothesis, that a parallel system acts as a celestial laboratory. Within the framework of known physics, the laws governing orbital mechanics are universal. Gravity behaves the same way here as it does in the farthest reaches of the observable universe. If another solar system, a near-perfect twin of our own, were to exist, its dynamical evolution would be a powerful predictive tool. By observing its state, we could forecast the long-term fate of our own planetary family, understanding instabilities, migration patterns, and resonant interactions millions of years before they manifest in our own sky. The mirror game, then, becomes a test for a navigation algorithm designed not for one star, but for a class of similar stars. The intricate pathways suggested by the mirror map are not merely efficient, they are instructional, a set of solutions to a universal problem of traversal. But who, or what, is the intended student of this cosmic curriculum? The implications of such a notion ripple outward, and we must consider them at three distinct levels of consequence. At the smallest, most localized scale, the optimal trajectories could indeed be a fortunate artifact, a beautiful and complex illusion born from the random mechanics of celestial motion. The gravitational interactions of billions of planetesimals over eons could have by chance settled into a configuration that our pattern-seeking minds interpret as a designed symmetry. It is a compelling argument from parsimony, a reminder that not all elegance requires a designer. Yet, does the sheer computational optimality of these mirrored paths, their uncanny efficiency that surpasses what random chance typically provides, not itself become a datum that demands explanation? Progressing to a medium scale, the hypothesis gains more profound traction. If the symmetry is not random, then the map is an intentional guide,